In this video, we're going to discuss the negative binomial random variable. So in what situation do you use the negative binomial random variable? Well, the same as you use the binomial. You have independent trials, which are success or failure, the same chance of success on each trial. So we'll assume we have a baseball team with a 40% chance of winning each game and a 60% chance of losing. So the negative binomial random variable figures out the chance that if you have, given you have a chance probability P of success on each trial, in this case 0.4, the probability you'll have exactly F failures before the S success. So this is the syntax. Negative binom.dist, put the number of failures, the number of successes, the probability of success in each trial, and false will give you the value for each number of failures. True will give you the cumulative, as we'll see. Okay, so let's again suppose we have a baseball team with a 40% chance of winning each game and a 60% chance of losing each game. What's the probably mass function, or the probability of each number of possible losses before the second win? 0 losses before the second win, 1 loss before they win 2 games, 2 losses, etc. Okay, so we would go equals negative binom.dist. Okay, so we can go to the function wizard. Okay, so the number of failures, that's the losses. The number of successes we said was 2. The chance of success was 0.4, and we can put in a false or a 0 to give you what's called the mass function. Okay, so that'd be 0.16, and we'll see where that comes from in a minute. Okay, just copy this down, and it's probably very unlikely they'd have 25 losses before their second win. They're not that bad. So these probabilities should add up to 1 approximately. 0.9998. If I want the chance of less than or equal to 4 losses before the second win. Now, that one we could figure out by just adding up 0, 1, 2, 3, or 4. Okay, or we could do a negative binom.dist. Okay, then I can get the function wizard. So the number of failures could be 4 or less, 2 wins, 0.4, but I could say true. And then I get the same result. So either way is fine there. Now, just to verify some of these, what's the chance you'd have 0 losses before the second win? Well, then you'd have to win the first 2 games, and that'd be 0.4 times 0.4 because the trials are independent. There's your 0.16. What's the chance of having 1 loss before the second win? You could have win 1, lose 1, win 1, or lose 1 and then win 2. And those add up to 0.096 times 2, which is 0.192. So that basically is a, I think, nice tutorial on the negative binomial random variable and the negative binom.dist function, which allows you to compute negative binomial probabilities.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.